Welcome to another IoT intro video. I'm your host Ulno, and today we will talk about power saving on the ESP8266, especially inside IoTempower. So for this, I have set up something for you. So we have here the Wemos D1 Mini, and I'm connecting this not directly with the shield on top of there, but with some cables, because later I will plug in this cable so that you can see it. But in general, you could potentially also just plug this in it. So this is the Dallas temperature sensor. So I have set up already something that measures temperature. But as you see, this here is plugged in to the directly to the wall power. And here we have a little power, very cheap USB power meter. As you see, at the moment, I have actually usually 0.02 amps of power draw. And that means, as we have 5 volts, it's 0.1 watts that we consume. It sometimes goes up to 0.05. You can say so that at the moment Wi-Fi is running, so it should kind of consume something between 20 and 100 milliamps for having the Wi-Fi running. So if you look at the software side now, we can actually see here that I get temperature values sent via the Wi-Fi network. So that's why we actually see some power draw, and see here in the room it's between 25 and higher 24 degrees centigrade that we get here. And you see it's kind of sent around every second we get kind of a change that is coming in here. So now we want to start to do power save. And so this mode for power saving on the ESP is called deep sleep. So if you look here on the commands, we can actually find some information for deep sleep. And this is here. And so there are a couple of new things here. So the main thing is that you have to use this start message, which you probably have never seen in IoTempower, which is basically something that when the device comes up is set. And as you see here, it calls, when it is started, the deep sleep function, where the first parameter means how long it should be awake before it falls asleep. And then this here says how long it should sleep before it wakes up again. But then if you read a little deeper in here, you should also see that remember to wire RST to D0 to make this possible, because on D0 it emits the signal to wake up, and then it basically resets the device to do the wake up. So you could manually just press the reset button, or you can use this. Or you can also build a device that if you push a button that also sends a signal to reset, then you can basically have a hardware wake up for it. But we want to look at the software wake up. We want to have not a temperature every second. We want to have a temperature every hour or every day to kind of have a long-term memory of kind of a remote temperature sensor to monitor it, and not to have to come and change the battery so often in between. So let's basically take this start function here and put it into the code. So I'm editing the setup. You see there is the Dallas temperature sensor already set up, and I just add the start function here. And we basically say, let's be awake for 5 seconds, and then let it sleep for 10 seconds until it wakes up. So remember, we forgot one thing, we have to put the wire in. So let's also put the wire in. And the wire needs to go from D0 to reset. D0 to reset. That's the first and the third up here. So you can actually see pretty nicely here the labels. So I'm going to connect RST and D0, which I did here on the device. And now it should wake up if we send it into the power mode, power sleep mode. So let's deploy this. And there's one thing I would actually say that could be important. Let's just make sure we reset the device once manually before we do all this. It's just good practice if we do work with the reset button to have one defined reset. So now it is booting up, and you already will see if we look at it, soon it will start blinking again. That means that it went through the power cycling mode. So also look at the consumption. See, now it blinks, and then now the amperage here should go up pretty soon. See, now it's at 0.2, and then after a couple of seconds it should fall asleep again, and now it's back at 0. So you see the power is actually dropping basically to 0 here. It doesn't mean that it's not consuming anything because we still have the voltage converter on this device, which kind of steps down from 5 volts to 3.3 volts to drive this device. So if you want to make an even more efficient device, you must make sure that also the power converter sleeps, so that you only use this chip here in the center. But even this kind of lets a normal battery run much, much longer when you already employ this. And you see, we see a couple of power cycles here. So let's check what that means actually on the software side. So we have here our MQTT listen, and you see at the moment there are no values coming through. But pretty soon, when the device boots up, we should see some values coming. So I'm seeing it already booting. And then it should send 1 or 2 temperature values after that. And see, there we get the 25 temperature value. So I will basically now rest my finger here on the temperature to heat it up. So we should probably see another power cycle now. And the next temperature value that comes through should be much, much higher. See, that is already at 27.5. We can also see the same thing in a Node-RED dashboard. So we are actually tracking this here. You see, if I now let it reboot, it should come up with a lower temperature value because I removed my finger from it. And see, the temperature is slowly going down. So as you see, it's just really adding this reboot option to it with the here in the start method, that it always should start up and send this and then send it to sleep and then wake up after this time again. There's just one huge issue. So if I now want to deploy this and the device is actually sleeping, then the deploy will actually fail. Let's see. As you see, it's now trying to upload, and it actually doesn't manage to upload something. So you might have to flash this device manually, or just get the timing right that you send the update in the moment that the device wakes up. We give it one more try, and if this also doesn't work, then we just say we might have to flash it manually. But you see, actually we've now managed to get the right time slot, and so we are able to do an update even if we have the power management enabled. Yeah, this is, as you see, quite easy. This way you can extend some simple sensors lifetime for quite a lot. So you can come up from maybe 1 or 2 days with one battery to several months with one battery. And I highly encourage you to consider this if you build systems that have to run outside in nature or in areas where you can't reach easily. So you might want to consider even saving even more power in removing the step-down converter that is on the board. But for simple experiments, this should bring you already very far. I hope you enjoyed this simple power management demo, and I can only say ciao and see you soon in the IoT Empire. See you.